All right. I want you to be on page 11 of your packet, and we're going to start geometric sequences. It's a lot like arithmetic sequence, but you should be easier. It should be easier to get this time. So go ahead and make sure you're on page 11. And we're going to skip and come back to the word problem. So don't think that you're not going to get that, okay? But page 11, it should be like this, all right? So if a sequence of values follows a pattern that is being multiplied, now I want you to highlight this or whatever it is that you need to do, just because I want you to realize that arithmetic we added. For geometric, we're multiplying a fixed amount, okay? And each term is going to be multiplied by that same thing every time. And that is how we know that it's a geometric sequence. So anytime it's being multiplied is geometric, added is arithmetic, all right? The number that is multiplied each time is called your common ratio. It's the R. Remember with arithmetic we did D. All right. Now, to do or to be able to find, and I'm highlighting this in a different color. That's why I'm pulling up that. So to find your common ratio, you need to divide the first term, or sorry, divide the second term by the first term. So all that is saying is you're going to do a sub 1 divided by. Sorry, I've got that all messed up. Let me erase that real quick. All right, there we go. Now, let's go ahead and get back to what we were doing. I'm going to re-highlight this screen real quick. There you go. All right, here we go. So that means all you're going to do is take and divide a sub 2 by a sub 1. Now, this is one thing y'all were having trouble with when we did arithmetic, but the first number is always your first term. The second one's always a sub 2, a sub 3, a sub 4, and so on. Okay, it'll continue on. So this will be a sub 5, and if we had another term, it'd be a sub 6, 7, 8, 9, however. So to be able to find that, we have to take and divide a sub 2, so a sub 2 is 4, divided by 2. And that's all this is right here. And then, of course, if you simplify it, you get 2, and that is your R. Okay? All right, next page. All right, so if you look here, we're going to see if this follows a sequence. All right, so 1 to 2, we add 1. 2 to 3, 3 to 4, 4 to 5. So all we did there is we went term 1, term 2, term 3, term 4, term 5. Now let's see how it's changing. All right, so we have 2 to 4. We have two options. We could take and multiply by 2, or we could add 2. So let's see which option that we have, okay? So we can add 2, or we can multiply by 2. All right? So let's see. If we add 2 right here, that will not give us 8. So we're going to have to multiply by 2. So that means that one's not going to work. And every time, let's just double check, 8 times 2 is 16. Is 16 times 2 32? Yes, it is. So that was correct. And if you see, it is graphed up here, our order of pairs. So 1, 2 is right here. 2, 4 is right here. And then it continues on up. And you can see that geometric growth, which is just like when we were doing the paper folding. And if you wanted to be a millionaire just by taking $1 million, or if you wanted Bill Gates to start out by paying you a penny every day. All right, so now we're going to write these. So the first one we're going to write is the recursive rule. Okay? So highlight this, mark it, whatever you need to do. So the recursive rule is this right here. That is your formula for your recursive rule. Okay? So a sub n is the nth term in your sequence, and a sub n minus 1 is the previous term. So underline this, and I want you to draw an arrow so you know that that's what we're talking about. But you have to have. So for that one, you have to have the previous term to be able to do the recursive rule, okay? And then R is your common ratio, which that's what we were just talking about and seeing how to find. So when we write the recursive rule or recursive formula, the only thing that you're going to do is replace R. So only replace R. That's it. So everything else stays the same. So you could actually go ahead and do a sub n is equal to, we don't know R, but we keep that a sub n minus 1 in parentheses. And then all we're going to change is the number that goes there. Okay? Now to find that number, we have to take a sub 2 and divide it by a sub 1. A sub 2 is 8, so we're going to do 8. And then a sub 1 is 4. 8 divided by 4 is 2, so that's what goes right here. And there you go. You've got your recursive rule for that sequence. Let's try it again. So a sub n, we don't know R yet, but we know that a sub n minus 1 stays. All right? So 30 divided by 10, that gives us 3, and that's what goes right here. Everything else just stays the same. All right. I want you to try the last one. So go ahead and try that. Pause the video, whatever you need to do to see if you get it. And then unpause to see if you get the same answer I get. So a sub n is equal to, we don't know R yet, and then a sub n minus 1 is multiplied. So negative 20 over 5. Don't forget that negative sign, so negative 4. So you should have, and let me write this a little bit better because that way you can see that negative. There you go. A sub n. All right. All right, go ahead and turn to the next page. So that's the recursive rule. Now we're going to do the explicit formula. Again, I want you to highlight whatever you need to do. Let me find my highlighter. So for the explicit formula, this is the formula that we need. All right? Now, when we have the explicit formula, we're going to replace the first term, which is a sub. Oops, I'm moving the whole screen instead of writing. Which is, we need a sub 1, which is the first term, and again, we need R. Okay? So when we're writing the explicit formula, we're just changing two things. We're only replacing R and a sub 1. And of course, a sub 1 is the first term. And you can look at it like if I was talking to you and saying, your grandfather's daughter has 3 kids. Another way to say that is my mother has 3 kids. You don't want to say my grandfather's daughter, my mother has 3 kids. You want to take and change that out. So you don't want to put a sub 1 and a number in the formula. You're replacing that a sub 1 with a value. Okay? So go ahead and write your formula. A sub n is equal to a sub 1 is being replaced, R is being replaced, and minus 1. And then we're going to find this. So if we look at the sequence, a sub 1 is always our first term. So 4 goes there. And then we've got to find R. Remember, R is a sub 2 divided by a sub 1. So if we do that, that is 8 divided by 4, which is 2. And there is your answer. All right, let's try the next one. A sub n is equal to n minus 1. Our first term is 10. So that goes first, and then we need to find r. So r is equal to 30 divided by 10, which is 3. There you go. All right, you try the last one real quick. Pause the video, try it, and see if you can get it. And then once you finished it, unpause and see if you got the same answer I got. So a sub n, we don't know what the r is yet. We do know what a sub 1 is, though. So a sub 1 is the 5. And then we do negative 20 divided by 5, which is negative 4. And there you go. That is your answer. All right. Go ahead and turn it to the next page. You need to look at those again. Go ahead. All right. So now we are given the explicit formula. So given the explicit formula for the geometric sequence, to find the first 5 terms. So in order to do that, all you're going to do is plug in. We're going to plug in 1 through 5. All right? So if we look at this, we have a sub n is equal to 3 times 2 raised to the n minus 1. Well, we want to know the first term. So a sub n is equal to 3 to n minus 1. Well, if we want to know a sub 1, if we look at this, that 1 replaced n. So we're going to do the same thing in our formula. So it's going to be 3, 2, 1, minus 1. All right? And this gives you 3, 2 to the 0, which is 3 times 1, which is 3. So a sub 1 is 3. All right? A sub 2, same thing. 3 times 2 raised to the 2 minus 1. That's going to be 3 times 2 to the first, which is 3 times 2, which is 6. There you go. Which is 6. All right, so we've got our first 2 terms. All right, I'm going to erase this because I don't have as much room and I'm writing a little bit bigger. All right, let's do a sub 3. So a sub 3 is equal to 3. And you could actually take and put this in the calculator. You don't have to do it by hand like I am. 2 squared, 3 times 4 is 12. And if you want to pause it and try it and see if you get the same answer as I do, you can do that as well. So a sub 4, 3 times 2, 4 minus 1. 3 times 2 to the third, and that's 3 times 8, which is 24. So a sub 4 is 24. All right. Again, I'm erasing just so that way I have room. All right, the next one we have a sub 5. So we did 3, and then nothing is changing except that n. Okay? That's 2 to the 4th. And that's 3 times 16, which is 48. All right, now be careful with this next one because it's not a to the 6th. It is actually a to the 12th. So we take this, a to the 12th is equal to 3 times 2, 12 minus 1. And that's going to give us 3 times 2 to the 11th. And our answer is going to end up being 6,144. So there you go. All right. So there's our work. Now, it says write the sequence and graph it. So if we want to write, to be able to graph, we've got to have ordered pairs. So for our first ordered pair, what did we plug in? We plugged in the 1, and we got 3. So our ordered pair is 1, 3. So for the next one, we plugged in 2, and we got 6. The next one, 3, 12, and you keep going. So 4, 24, and then 5, 48. And of course, we're not going to be able to graph some of these, so just write them down. 6,144. All right, so graph what you can. So at 1, we're at 3. At 2, we're at 6. And then at 3, we're at 12, which is right there. Now, that's all we're going to be able to get on our graph, but that's fine. You don't have to put any more on there. Okay? Now, what did you notice as we were doing this? And if you look at it and you pay attention to it, you should have noticed that the y values doubled every time. I want you to look at this real quick because now you can see a pattern, all right? If I see this, my first term that I started out with was 3, okay? That's what I started out with. But if I multiply this by 2, then I got 6. And if I multiply by 2, I get 12. So I went up by 2 every time. Now look at our equation. We started out with 3, and then we multiply by 2 every time. And that's exactly how this works. So the next one, we're going to try it real quick. Without, we're going to write our formula and everything. But then I want you to try, we're going to see if we do it, and then we'll do the work. All right? So we've got the first term in the sequence, and we've got the ratio. So we're going to write the explicit formula. Now, remember, the explicit formula is a sub n is equal to a sub 1 times r raised to the n minus 1. And we're only going to change a sub 1 and r. Okay? So if we do that, let's go ahead and run our formula. A sub n is equal to our first term is 4, so 4, and then r, so 2 raised to the n minus 1. All right, let's try this real quick before we write the sequence, okay? So if we plug in 1, 2, 3, 4, and 5. Let's just see. All right, so our first term should be what they give us, which is 4. Now, if we multiply it by 2, 4 times 2 is 8. Multiply 8 times 2, because that's what we're changing by. So we start out with 4, multiply by 2. We got 8. Multiply by 2 again, 16 by 2 again, 32 by 2 again, 64. Now, before we graph it, let's check it and see. Okay, so we have a sub 1 is equal to 4. I don't need that parenthesis before the 4. Let me fix that. 4 and then 2, 1 minus 1. If you put that in the calculator, it gets 4, which gives us 1, 4. Okay, that one should have worked out, so we're good there. So if you want to go ahead and plot it, and I can't see my graph ticket on here, but you should be able to see yours pretty good. A sub 2, 4, 2, 2 minus 1. That is going to give you 8, which gives us 2, 8, which actually is what we have here. All right, let's do the next one. A sub 3, 4, 2, 3 minus 1. When you put that in the calculator, you're going to get 16, which is 3 16. If we look, they're checking out. Now, it looks like the last one we're going to be able to graph, but it's okay. All right? So a sub 4, 4, 2, 4 minus 1. If we plug that in, we get 32. All right, and that one checks out as well. And we've got one more, a sub 5, is equal to 4. 2, 5 minus 1 is equal to 64, which is 564. And there you go. So they all checked out. So see how if you have your first term and then you multiply by what your ratio is every time, you're going to get the right answer. All right. I want you to try the next ones on your own. However, I'm going to go ahead and do them real quick just so you have them. So pause the video, try these, and then see if you've got it. So R is 10 divided by 2, which is 5. So my explicit formula is A sub n is equal to my first term is 2. My ratio is 5, n minus 1. That's it. All right, for the other one, R, 16 divided by 4 is 4. So A sub n is equal to my first term, which is 4. And then my ratio is 4, n minus 1. And that's it for that one. Now, for this one real fast, just write your recursive formula, and you're going to replace R. Ooh, I'm highlighting now. Make sure I'm still in the, so replace. We don't have a, there you go. Replace R for this one. And then for the explicit formula, we're going to replace R and A sub 1. All right. So go ahead if you want and do this. You're just going to replace the R on the first one. So you just need this one for here. And then for the second one, for the explicit formula, you're going to replace A sub 1 and R, which A sub 1 is 6. And to get R, we're going to do 30 divided by 6, which is equal to 5. So 5 goes here, and 5 goes here. So if we wanted to graph that one, we would start out with 6 and multiply by 5 every time. And then you would be able to graph it, and you would have your sequence. All right, so I want you to take this and practice it as many times as you need to. And if you have any questions, please feel free to come and ask.